A few months ago, astronomers spotted a true spacetime speedster zipping through outer space, presenting experts with a new perplexing mystery. Officially named Quis J11249+3621, this peculiar celestial body is a remarkably small yet incredibly fast-moving star, hurtling through the Milky Way at a staggering speed of 1.6 million kilometers per hour. However, its origin, the source of its astonishing velocity, and even its exact nature remain unknown. The cosmos is in constant motion, and our Sun is no exception. Every year, it travels approximately 940 million kilometers, cruising through space at 107,000 kilometers per hour, about 30 times the speed of a bullet. While these figures may seem extraordinary, they are relatively modest in astronomical terms. In fact, most stars orbiting the Milky Way's center move at similarly measured paces. Yet, some celestial objects defy this norm, living up to their designation as high-speed travelers. These so-called hypervelocity stars move at phenomenal speeds of 300 to 1,000 kilometers per second, fast enough to overcome the Milky Way's gravitational pull and escape into intergalactic space. Astronomers have already identified hundreds of these cosmic speedsters, often appearing as blue giants, binary systems, or remnants of supernova explosions. 30% of fast-moving stars are believed to have an extragalactic origin. But what exactly propels a celestial body to such incredible speeds? The leading theory suggests that most hyperfast stars owe their velocity to a turbulent past, specifically, the cosmic upheavals they narrowly survived. According to this idea, these stars were either expelled from their original binary system or had a close encounter with a black hole. At least, that's the prevailing hypothesis. A few months ago, astronomers discovered a hyperfast star that has left them puzzled in several ways. Interestingly, the researchers weren't specifically searching for an exceptionally fast-moving star. The discovery came through the citizen science project Backyard Worlds, Planet 9, where volunteers aim to locate the elusive ninth planet and nearby brown dwarfs. As part of their efforts, participants analyze specialized infrared images captured by the WISE Space Telescope, which scanned the sky from January 2010 until it burned up in Earth's atmosphere last November. While confirmation of a ninth planet remains pending, 3 amateur astronomers recently spotted a faint object moving at an unexpectedly high speed. Co-discoverer Martin Kutnick from Nuremberg initially believed that such a rapidly moving celestial body must have been documented long ago. However, that was not the case. As a result, a team led by Adam Burgasser from the University of California, San Diego, set out to study this unusually fast object for the first time using the Keck 2 telescope in Hawaii. Following the announcement of the discovery and a subsequent examination with a high-resolution spectroscope, it became clear that the stellar lead foot is hurtling through the Milky Way at an astonishing speed of approximately 524 kilometers per second. Traveling at approximately 1.6 million kilometers per hour, astronomers soon recognized that the object, designated CJ11249+3621, might be moving fast enough to break free from our galaxy. What makes this speeding star a challenge for experts? In addition to its incredible velocity, it has drawn attention due to its close proximity to the solar system. Situated just 400 light-years away, it holds the title of the nearest known hyperfast star to Earth. Regarding other exceptional stars in our cosmic vicinity, experts note that fewer than 0.002% of stars within 650 light-years of the Sun display comparable tangential, or, in simpler terms, orbital, velocities. Yet, despite this distinction, the trajectory of this rapid traveler is also unusual in another way: it moves transversely to most other stars. This means it is currently heading toward the center of our galaxy, will pass it at a distance of roughly 3,000 light-years, and will eventually escape the Milky Way. Whether the star will fully break free from the gravitational pull of our galaxy remains uncertain. While about 15% of predictions suggest it will leave the Milky Way permanently, the rest remain inconclusive. Adding to its intrigue is its exceptionally long and eccentric orbit, spanning around 3 billion years. Spectrographic analysis reveals that this star has a mass of only 0.083 times that of the Sun, making it remarkably small. Most previously identified hypervelocity stars are much larger, typically ranging from 3 to 8 solar masses. In fact, this newly discovered object barely exceeds the minimum mass required to ignite and sustain hydrogen fusion. Given this, experts suggest that the swift traveler might either be a faint subdwarf or even a brown dwarf, an elusive class of celestial objects that straddle the line between stars and planets, often referred to as failed stars. But beyond its uncertain classification, another mystery lies in its unusual composition. Studies show that the star is extremely metal-poor, containing only trace amounts of elements heavier than hydrogen and helium. This chemical makeup indicates that the object is likely very old, possibly even a relic from the earliest generation of stars in the Milky Way. But the bigger question remains, what propelled this ancient celestial body into such a high-speed journey in the first place? As for the answer, whether it involves exploding white dwarfs or cosmic collisions, scientists have yet to reach a definitive conclusion. However, the star's path and properties allow them to explore some plausible theories. One possibility is that it once belonged to a binary system with a white dwarf. At some point, its companion underwent a supernova explosion, catapulting the smaller star into rapid motion with a significant speed boost. Calculations suggest this scenario is entirely feasible. Another theory involves a more chaotic origin, a kind of cosmic bowling alley. The star may have once resided in a densely packed globular cluster, where close encounters between stars and black holes are common. If a star drifts too near a binary black hole system, gravitational interactions can violently eject it from the cluster. This could explain the hyperfast runner's trajectory. However, no known globular cluster aligns with its reconstructed flight path, leaving this possibility unresolved. Another open question is whether the star had a near encounter with Sagittarius A*, the supermassive black hole at the heart of our galaxy, which might have flung it from its original orbit. The true origins of this stellar speedster remain shrouded in mystery. To uncover its past, further physical and atmospheric analyses will be essential. Each of the proposed scenarios should have left distinct chemical fingerprints in the star's gas envelope. Identifying such elemental traces would be a crucial step towards solving the mystery of this extraordinary traveler. Only time will reveal the full story. Astronomers are making strides in this field, but if we shift our focus to the past, we'll find a star that makes even the one just mentioned seem sluggish. The fastest star in the Milky Way, because let's be real, what is 1.6 million kilometers per hour compared to a staggering 86 million kilometers per hour? That's right, you heard correctly. In 2020, astronomers identified a celestial body, S4711, orbiting the Milky Way's central black hole at an almost mind-blowing speed of 24,000 kilometers per second. That's a remarkable 8% of the speed of light, allowing it to complete a full orbit around the black hole in just 7.6 years. This record-breaking speedster was detected in observation data from the Very Large Telescope in Chile. However, it only reaches its peak velocity when it nears the immense gravitational pull of the black hole. Further away, its average speed drops to about 0.5% of the speed of light. But what makes S4711 truly fascinating is the possibility that it belongs to a theoretical class of stars known as squeezers. These stars, predicted in theory but never confirmed, travel along highly eccentric orbits around a supermassive black hole. As they approach, they experience intense tidal heating, only to cool down again as they move away. Squeezers can reach scorching temperatures of several thousand degrees, and indeed, analysis of S4711 reveals a peak temperature of around 10,000 Kelvin, nearly twice as hot as the Sun's surface. But S4711 isn't alone. Several stars have been discovered in the vicinity of our galaxy's central black hole. How is this possible, given that the black hole's extreme tidal forces should prevent star formation in its surroundings? Experts believe these stars likely didn't form there but were instead captured and held in place. One theory suggests they were originally part of binary star systems that ventured too close to the black hole. In such cases, one star would be pulled into the black hole's gravitational grasp, while the other would be ejected, hurtling through the galaxy as a hypervelocity star.